All right, psychology students, we've entered exam cram time. So it's imperative we take as many practice exams as we can before the big day. Now this video is part of a larger series on how to approach and of course master multiple choice questions. Remember, roughly 2/3 of your overall AP Psychology exam score is on the multiple choice section, so we must master this area. Now in all the videos, we're going to be using questions from Barron's, a really great test preparation resource. Now in this video, we're going to start with Unit 1, Scientific Foundations of Psychology, covering research methods, statistics, and ethics. Arguably the most important unit in psychology because it establishes psychology as a scientific discipline. So if you're ready, let's get to it. Now before we begin, I highly recommend for you to pause the video, read the question, think about what the answer is, and then watch and see if my answer aligns with yours. All right, let's get started. Number 1. Tamil wants to see whether listening to Mozart will improve students' performance on geometry exams. It is most important that our experimental group consists of. Now, how do I know what the experimental group is in a study? Now, whenever you're dealing with an experiment, and I know this is an experiment because A, it talks about experimental group, and 2, it talks about Mozart will improve. Why is that important? Because an experiment is the only method that can establish causality, right? Mozart will improve scores. A survey can't do that, and a correlation can't do that, right? All right, so when we deal with an experimental group or experiment, I want this visual to come to mind. 3 circles. How many? 3. We have 1, 2, 3. Why do we have 3 circles? It's because when you're dealing with a study or an experiment, start with a sample that's really easy. You're going to equally divide that sample into 2 groups. 50 here, 50 here. This is the visual for an experiment. Because one group is going to be our experimental group. What do they receive? The independent variable. And the other group is what? Our comparison group or our control group. What do they get? Nothing, or possibly the placebo. So have this visual in your head whenever we're talking about an experiment. All right, what are our answers? A, students who already listen to Mozart. Well, I want students to listen to Mozart during this study to see if it affects geometry score. So we're going to cross that out. C, students randomly assigned not to listen to Mozart. Well, that would be our control group. So that can't be our experimental group. D, students who have already completed geometry. And E, students who have never studied geometry. Well, geometry is our dependent variable, right? We want to know if Mozart impacts our geometry scores. So that has nothing to do with our experimental group. That can't be right. That can't be right. Which leaves B, students randomly assigned to listen to Mozart. And that is our answer. What is our independent variable? Listening to Mozart. Number 2, a principal difference between a longitudinal study and a cross-sectional study is the. Now, what stands out to me is that longitudinal and cross-sectional are typically 2 methods used in developmental psychology, right? When we're studying babies or infants or adolescents or adults, these are primarily the 2 methods. Now, what is the difference? A longitudinal study, kind of right up here, is when you study one individual or group and you follow them for a long period of time. So maybe I study Sam, right? And I study Sam at 10 years old. I study him at 20 years old. I study him at 30 years old. And maybe I want to see how his memory improves or declines as he ages. So what is a cross-sectional study? A cross-sectional study is when I study different people at the same time. Maybe I study Sam, who's 10. I study Dan, who's 20, and I study Sarah, who is 30, right? And I want to know how their memory differs across ages. So, longitudinal and cross-sectional. Let's take a look at our answers. A, number of participants involved. Well, I can have 1,000 participants in each one. That doesn't matter, so we're going to cross that off. B, developmental stage of the participants. Well, look, I can have 10-year-olds in my longitudinal study and 10-year-olds in my cross-sectional study, so I can cross that off as well. Letter D, statistical methods employed to evaluate the data. I can use surveys across both, right? I can do case studies, so that doesn't matter. We're going to cross that off. E, sampling method used to choose participants. I can do the same method of sampling. I can do, every 5th person who walks into a building or whatever it may be. Which leads us to C, time span of the study, right? A longitudinal study can take decades because I'm following the same person. Cross-sectional is very brief. And a nice memory technique is longitudinal is a very long study. So there we go. Our answer is C. All right, number 3. Mr. Maggi gives a test to his class of 25 students. All but 3 students score between 82 and 94. The other 3 students score 47, 55, and 62. These scores are potential. Now, what stands out to me is all the students score between 82 and 94, right? Which means most of them are going to be clumped together, with a few exceptions of these, right? These are the ones that are very far away from the other students. So one thing I do is kind of visualize this together, right? So imagine, right, as a teacher, all my students take a test, right? And all the students score between, what do they score between? 82 and what? 94, right? In fact, I'd be very happy as a teacher if that happened. But there are 3 students, maybe they didn't study, score well below. We have a 62, right there, right here. We have a 55, and we have a 47, right? These scores are so far away from the average. What are these called? Can they be modes? Well, modes is the most frequent, right? So we're going to cross that off. Skewers. Well, typically we talk about skewed. We talk about like a positively skewed or negatively skewed, right? You know, maybe a graph that looks like this. Nothing to do with these kind of scores that are so far out. Now, letters D and E are roughly the same thing, variances and standard deviation. That's how far scores are away from the mean. And yes, these are far away, but it's really not talking about these scores in particular. So we're going to cross these out, which leads us to C, outliers. Why is that the answer? Any score that is so far away from the average, these are the extreme scores, and we call these outliers. All right, number 4. Professor Mao wants to design a project studying emotional response to date rape. Okay, so there's our study. We want to study emotional response to date rape. He advertises for participants in the school newspaper, informs them about the nature of study, gets their consent. And by the way, when I see the word consent, I know they're talking about ethics, so we got to get informed consent at the beginning of the study, conducts an interview, debriefs, which occurs at the end of the study, debriefs them about the results of the experiment, is over. If you were on the IRB, the Institutional Review Board, they determine when the experiment should be conducted. Is it, do we put participants at risk? Which ethical consideration would you most likely have the most concern about in Professor Ma's study? All right, so we know we're dealing with ethics. So right off the bat, I'm probably going to cross off confounding variable. This doesn't really have to do with ethics. It's more about different variables that might affect the dependent variable, right? Things that you don't account for. Now, could it be clear scientific purpose? It could, but this also doesn't really have to do with ethics, right? It's actually a very clear study. Everything is laid out here. So what could be our answers? Could it be coercion? Well, coercion is when you force people to be in a study. And guess what? We informed them about the nature of the study. They signed up. They gave consent. So there wasn't any coercion. What about deception? Well, deception is when you lie to participants, right? You don't really tell them the truth. But if you have debriefing, that's when you tell them about the deception, right? So that's not going to be your answer. So what's our answer? Well, because we're dealing with date rape, it is such a sensitive topic, I'm worried that information might get out there to the public about who's actually in my study, right? So confidentiality is about privacy, and we're dealing with a topic like that, that would be my concern. All right, number 5. Psychologists generally prefer the experimental method to other research methods because. Now, what did I say before about an experiment? What visual do we have in our head? If you're thinking 3 circles, we start with our sample, a nice even number, right? And we equally divide them using random assignments, right? That's what I want you to do, okay? We have our classic experiment, and what are our 2 groups called? We have our experimental group. They have the independent variable, our treatment, and the control group, right? They get nothing or possibly a placebo. And if you want to take this further, what we want to know is, does the independent variable have an effect on the dependent variable, right? If we isolate this one, is it going to actually have an effect on our data? Or maybe it's just, something in our head like a placebo, right? So there's kind of our visual of our study. All right, so what do experiments do that others don't? A, experiments are more likely to support psychologists' hypothesis. Well, you can do surveys, you can do case studies, you can do a lot of different methods that support hypotheses. An experiment isn't the best way to support a hypothesis. That's just one way. Letter C, it is easier to obtain a random sample for an experiment. I can do a survey, I can do a case study. There's a lot of ways I can get people into my study from the population. Experiment is not necessarily one of them. Letter D, double-blind designs are unnecessary in experiment. Well, actually, it's the opposite. Double blinds are perfect because the participant and the researcher don't know who's in what group. So we're going to cross that out. Letter E. Experiments are more likely to result in statistically significant findings. Now, yes, experiments are wonderful, but there's a lot of methods you can do, right? Longitudinal, cross-sectional, to get really good findings. An experiment is just one of those. Which leads us to B. Experiments can show cause and effect. When we talk about causality, that's why we do experiments. We isolate a variable and we want to know, does this have an effect on our dependent variable? Our answer is B. Number 6, which of the following is an example of random sampling? Now, a couple things to think about. They're going to trick you up on the AP test. We have two terms, random sampling and random assignments. Make sure you know the difference because they're going to get you on this one. So let's go over that very quickly. When you start with a study, we have what we call a population, right? And then from that population, we have to do random sampling. Okay, imagine we have 100 people. And you get a sample out of that population. So here's our sample, I'll put a little S there, and maybe we get 20 people from our population. That's random sampling. Everybody in the population has an equal chance to be in our study. So what's random assignment then? Let's go to our experiment. How many times do we have to do this? We have our 3 circles, we have our 100 subjects, and random assignment deals with experiments. RA, random assignments. Everybody has an equal chance to be in one, my experimental group and my control group, right? Even just putting names in a hat and picking them out is part of random assignment. So don't confuse those. They're going to try to trick you up. All right, so which of the following is random sampling? Number 1, picking out of a hat to assign each of 3 classes to an experimental condition. All right, this is the distractor. They want you to pick this answer. Now, experimental condition is random assignment. So number 1 cannot be right because they're really talking about random assignments, not random sampling. All right, let's go to number 3. Approaching any 50 students during 6-period lunch. Now, I know that sounds random, like just picking students. But in psychology and across the sciences, there is a system to randomization, right? We are systematically randomizing people into 2 groups. So it's not just kind of looking around for people. So we're going to cross that off. Which leads to number 2, having a computer generate a random list of 100 high school students. So out of all the high school students, we have a generated random list. This would be our best answer. So it is number 2, which means our answer is B. All right, number 7. What is the median, I'll underline median, of the following distribution? 6, 2, 9, 4, 7, 3. All right, what's the median? The median is the middle, okay? It's a measure of central tendency. We want to know which number? Right dab in the middle. The mean is the average, the mode is the most frequent. So how do we establish the mean? We put the numbers in order from lowest to highest. So let's do that together. We have 2, cross that off. We have 3, cross that off. We have 4, cross that off. We have 6, putting them in order. We have 7, and we have 9, okay? All right, there's our distribution. Now, how do we find the median? Well, there really isn't a middle because there's 2 numbers. So what do? We add them up together. 4 plus 6 is 10. We divide that by 2 because we have 2 numbers, which equals 5. And that is our median. So no A, C, D. Our answer is B, 5. All right, number 8. Farnaz randomly selected 50 new mothers to interview out of the 362 new mothers who gave birth in Random City Central Hospital during the summer of 2011. Now, one thing it sends out to me says out of. And if it says out of, they're typically referring to the population, right? Out of this many people, right? So our population, right, something like this. What is Farnaz's population? All right, so if we're talking about population, we should think of 2 words, sample and population, right? Typically our answer is going to be somewhere in the middle there. So how do we determine that? Once again, let's have a visual. We have a giant circle. Here's our population. What's our population? That's everybody in an area who has the potential to be in my study. Okay, so there's my population. What is it? It is 362. That's my population of new mothers who gave birth at Random City Central Hospital. So I'll say R, abbreviate this, RCCH, Random City Central Hospital. That's my population. And my sample is, I randomly selected 50, okay? So out of that, my sample is 50, okay? Using some sort of random sampling. Population, I'll put a little S there for sample. All right, so my question is, what is Farnaz's population? What's our population? Is it A, new mothers in random city hospitals? Well, I don't care about all the hospitals. I just care about this hospital, right? Random City Central Hospital, right? So that's not our answer. I don't care about all of them. B, new mothers in urban areas in the United States. Well, that's, first of all, nothing discussing about urban areas. We don't care about all the United States. That's just too broad, so we're going to cross that off. C, new mothers throughout the world. Too broad, right? We don't talk about the world. We don't talk about globalization. We're focusing on just the people who have the potential to be in our study. We're going to cross that off. D, the 50 new mothers with whom Farnaz speaks. Well, that's the sample right there, so that can't be our answer, which leads us to E, the 362 mothers at central hospitals that summer. That would be our answer. We have our sample of 50 drawn from the population of 362. All right, number 9. In a normal distribution, all right, we'll end there. What is a normal distribution? All right, let's draw this together. A normal distribution is often called, what? A bell curve. All right, why is it called a bell curve? It's because all the data centers in the middle, which means the mean, the median, and the mode are directly in the center. The average, the middle, and the most frequent are always in the center. Okay, so this is what we mean by normal distribution. It is a bell curve. The other thing we know about a normal distribution is what we call, I'll write this over here, the 68, 95, 99.7 rule. Okay, what does this mean? We should always think about that with the normal distribution. It means we talk about standard deviation, which is how far scores are spread out from the mean. One standard deviation, which is both sides, roughly 68% of the scores are within one standard deviation, okay? 2 standard deviations is roughly 95% of scores. And within 3 standard deviations, we got big here, almost all the scores will fall within 3 standard deviations. Not all, but most, 99.7%, okay? So this is our normal distribution curve. All right, let's look at our answers. A, 95% of the scores fall within 1 standard deviation. Well, that can't be right because 1 standard deviation is 68%, right? I'll even write a 1, 2, 3 here, just so you can see it, and a 1, 2, 3. That can't be right. It's got to be 68. All right. B, everyone scores within 3 standard deviations of the mean. Well, guess what? You don't have a limit to standard deviations. You could have 1,000 standard deviations, so we know that's not true. C, the mean is always greater than the median. Guess what? When you have a normal distribution, the mode, the median, and the mean are always the same, so they're not different. That cannot be right. Let's go to letter E. The standard deviation is always less than 1.0. Well, if you see 1.0, that's talking about a correlation, okay? Which we're not referring to. So that can't be right, which leads us to D. The mean, the median, mode are all equal. Our answer is D. All right, number 10. Which of the following hypotheses would be most difficult to test experimentally? All right, what do we got to do? When we think about experiments, how many circles? 3. All right, we have our circle. We got our 100 participants. I know we always come back to this, but that's our visual. And we randomly assign them, RA, random assignment. 50 go into our experimental group. 50 go into our control group. There's our setup, right, with experiments. So what would be difficult to test experimentally? Let's look at our answers. A, people exposed to the color red will be more aggressive than those exposed to the color blue. Well, I think we could do that. My experimental group, you get red, okay? And maybe my control group, you get blue, or something like that. And I see if it has an effect on your aggression, which is what? Our dependent variable. Easy to do. So I'll cross that off. That's an easy experiment. B, exercise improves mood. Well, I can do that, right? My experimental group, you're going to exercise, okay, you're my independent variable. My control group, nothing, right? You just sit there on the couch. Will that improve your mood, our dependent variable? Could. We're going to cross that off because, yeah, that could be an experiment. C, exposure to vitamin television increases aggression. Well, guess what? My experimental group, you're exposed to a violent TV, put VT. Control group, you're exposed to non-violent TV, right? Non-violent TV. And I see, does it affect your aggression? Once again, we're going to cross that off because, yeah, that's an easy study. All right, letter D, studying leads to better grades. All right, let's cross this off. Guess what? My experimental group, you're going to study 5 hours a day. My control group, no studying. Does it affect your grades? We'll find out. But we're going to cross that up because yes, you can definitely study that, which leads us to E. Divorce makes children more independent. Now, why is this our correct answer? I want you to think about this. We have 100 married couples, right? And I tell them, half of you get divorced and half of you stay married. That's completely unethical. And I can't do that, and nobody would agree to that study. So it sounds great, but we can't force people to get divorced. Therefore, that would be our correct answer. All right, number 11. Talia collects survey data. So we're collecting survey data that indicate that students who spend more time preparing for the AP test tend to score better than other students. Jen can now conclude that. All right, a couple things stand out to me. When it says Jen can now conclude that, they are going to try to trip you up, okay? They're going to make you think there's a causal relationship, right? Anytime you have a question about correlations or surveys or case studies, there's always going to be an answer that's going to make you choose causality, that X causes a change in Y. So look out for that with our answers. The only thing a survey can do is really show a relationship between things or, an association. It really can't, just gathering data, it really can't show causality. All right, A, studying improves exam grades. Well, guess what? If I have to prove studying, our independent variable, improves exam grades, our dependent variable, I need an experiment to do that. This is an experiment. It's only a survey. All right, C. A significant correlation exists between studying and exam grades. Now, yes, there could be a relationship between studying and grades, but they use the word significant. I don't know if it's significant. There's no extra data there, so I'm going to cross that off, right? That's kind of my buzzword that I need more information. All right, D. Anyone who does not study do poorly on the exam. Well, that's talking about causality, right? I cannot prove that if you don't study, you're going to do poorly. Only an experiment can show that. Lastly, letter E, better students tend to study more. Once again, that's causality. Students, I do an experiment, students who study do better. That's causality. Which leads us to our answer, letter B. A relationship exists between studying and exam scores. That is the only thing a survey can show me. Number 12. Charlotte and Tamar are lab partners assigned to research who is friendlier, girls or boys. After conversing with their first 10 participants, or there's 10 people in the study, they find that their friendliest ratings differ. All right, so they have different ideas about what is friendliest. With which of the following should they be most concerned? All right, so here we go. We have two people. We have Charlotte, one partner, and Tamar, okay? And they're both looking at boys and girls, okay? With all these questions, I want you to visualize what's happening, okay? So they're both looking at boys and girls. And essentially what they're doing is saying, how friendly are you? So imagine on a scale of, 1 to 10, Charlotte says, 5.2 friendly. And Tamar says 8.6. What's happening? They disagree on who is friendlier, which means they have a disagreement on what friendliness is, right? This kind of comes back to operational definitions. They don't have an agreement on what is friendly, okay? Which means their scores are inconsistent. Their thoughts are inconsistent, okay? Does this lead us to our correct answer? I think so. All right, which of the following should they be most concerned? Let's start with B, confounding variables. Now, confounding variables is anything that affects the dependent variable you don't really account for. Nothing that really has to do with friendliness ratings or inconsistency. All right, does it deal with ethics? Well, there's no lack of informed consent or coercion or deception. It's just a simple study watching boys and girls see who's friendlier. D, validity. Now, this deals with the accuracy of friendliness, right? Do they both have an understanding of what friendliness is? And they have a scale. They might not agree, but they do have a scale of what friendliness is. And lastly, letter E, assignment. Well, we're not dealing with an experiment. We're not randomly assigning. We're just kind of looking at people. And this leads us to our answer, which is A, reliability. Why is that A? It's because they both disagree on how they actually measure friendliness, right? So there's a lack of consistency in their friendliest ratings, right? There we go. It is inconsistent. We call this lack of inter-rater reliability. All right, number 13. Olivia, a nursery school student, hypothesizes that girls have fights with the finger paints more than boys do. She tests her hypothesis by casually watching, I'm going to underline that, I'll tell you why in a moment, casually watching the finger painting table for 3 days of nursery school. What method is she using? Now, In psychology, when we are watching something, we use the word observe or observation, right? That's kind of a fancier word for observing, right? We're not interacting with our subjects. We are just standing around watching them. And we want to know, as the question says, do they have more fights with the finger paints than boys do? All right, so what method is used? Well, A is field experiment. This is an experiment in the real world, right? You do have experimental control groups, but you're actually watching people out in the real world. We don't have an experimental control group. We're going to cross that off. B, informed survey. Well, there's nothing about a questionnaire. We're not giving a survey to our people. We're just watching them. So we're going to cross that off. All right, C, case study. Now, a case study is kind of a unique case, somebody who's something about them that's unique, and we talk to them and we interview them. We're not interacting with them, we're just watching them. So we're going to cross that off. All right, what about ethnography? Well, ethnography is when you immerse yourself in a culture and you become part of the study. Well, there's no immersion. All we're doing is casually watching, which is why our answer is D, a naturalistic observation. You stand far away, so to speak, you watch, you collect data, but you never interfere. All right, number 14. Sabrina finds a strong negative correlation. All right, a couple things. I'm going to underline strong, negative, and correlation. These are really important words. Between hours spent meditating and reported stress levels. Her findings indicate that. All right, let's kind of break down these words. When we're talking about a correlation, a strong correlation means that our correlation coefficient is close to 1.0. Now, it could be negative or positive, but 1.0 means very strong. Negative means, all right, negative, that our variables go in opposite directions. The presence of one variable predicts the absence of another. I do this with my students. We have our hands. This is positive correlation. This is a negative correlation, right? So what we're saying is the hours spent meditating, so the more we meditate, right there, reported stress levels decreases our stress levels. Okay, so there's our strong correlation. The more you meditate, there's a relationship, the less stress you have. All right, let's take a look. Oh, by the way, this is also really important. Whenever you have a question about correlation, you know they're going to deceive you. The AP people are going to put a question in or answer in about cause and effect. Okay, they want you to mix it up. Remember, correlation does not apply causation, so don't fall for it. All right, letter A. If a person meditates daily, she or he will not experience any stress. What did I just say? This is talking about causality. I can't prove that if you meditate, you will not experience stress. Only an experiment can tell me that. All right, letter B. People who meditate a lot tend to have higher stress levels. Well, guess what? That's a positive correlation, right? We have a negative correlation. The more we meditate, there's a relationship, the less stress. So that cannot be our answer. All right, let's go to letter C. Meditation lowers stress levels in humans. Once again, cause and effect. I cannot prove meditation lowers stress. Only an experiment can show that. All right, let's go to letter E. The failure to meditate is a major cause of stress in humans. Well, guess what? The moment I see the word cause, when we're talking about correlations, that screams not the correct answer, which leads us to D. People with lower stress levels meditate more than people with high stress levels. That's the only thing we can conclude because we cannot establish causality. D is our answer. All right, number 15. Which technique controls for both experimenter bias and subject bias? Now, we have experimenter bias and subject bias. The first thing to think about is, what is bias? Well, bias is when you have a little prejudice, right? You answer in a way based on your preconceived notions about something. We don't want bias, right? We just want you to answer something without being prejudiced. So how do we eliminate those? Well, it could be A, demand characteristics, but those are kind of little hints that an experiment might give you about how to react. It doesn't necessarily eliminate bias in both. Let's go to letter C. Single blind study. Now, this kind of is the correct answer. Whenever I talk about blind studies, I always have my students kind of imagine somebody's blind. And basically what this means is that the experimenter, okay, the researcher, doesn't know who's in the experimental control group. They might have an assistant, for example, collect data. So the experimenter doesn't know. But that doesn't deal with the subject, so we're going to cross that out. The Hawthorne effect. Now, the Hawthorne effect is this very famous study where people change their behavior when they're being watched. Nothing to do with bias. And lastly, counterbalancing is kind of like confounding variables, something that might affect our results. Or cross that out. That doesn't really deal with bias. Which leads us to double-blind study. What does it have to do with experimenter subject bias? It's because in a double-blind, as opposed to a single-blind, both the experimenter and and the subject, experimental subject, don't know who's an experimental control condition. They might have a placebo, for example, but they don't know they have the placebo, and the experimenter also doesn't know who has the placebo. Therefore, our answer is B, double-blind study.